the third quantum number, which is the magnetic quantum number. This quantum number is the one that's going to show us why we know that there's only one s orbital at each level, and why we know that there are 3 p orbitals and 5 d orbitals and 7 f orbitals. This is the number that tells us that because it's the orientation of the orbital in 3D space. So this number tells us how many orbitals there are in any specific sublevel. The symbol for the magnetic quantum number is m sub L because it's related to L, the sublevels. The values of m sub L range from negative L to positive L. So when n equals 1, L equals 0. Therefore, negative 0 to positive 0, of course, m sub L is going to equal 0. Because there's only one number for m sub L, that tells us that there's only one orbital. When n equals 2, there are 2 sublevels, L equals 0 and L equals 1. So the maximum values of m sub L is negative 1, 0, and 1. So when L is 1, m sub L is negative 1, 0, and 1. There are 3 numbers there. So the px has one value, the py has the other value, and the pz has the third value. Because there are 3 values, we know there are 3 sublevels. M sub L equals what in this case? When n is 3, you got 3 different L values because there are 3 sublevels. So when L is 0, M sub L is 0. When L is 1, M sub L is negative 1, 0, and 1. And when L is 2, what do you think the M sub L values are going to be? That's right, from negative 2 to positive 2. So you have negative 2, negative 1, 0, 1, and 2. There are 5 values that I've just listed. Those correspond to the 5d values. That's why we know there are 5d orbitals. The last quantum number is called the spin quantum number. The electrons are not stationary particles. They spin. We know they spin because of the magnetic fields that we find in the atom. The symbol is m sub s. They can spin in 2 directions. We have assigned them randomly terms like clockwise and counterclockwise. They spin one way or they spin the other way. The values of m sub s have been randomly assigned by scientists. They're positive 1/2 or negative 1/2. So there are the 4 quantum numbers that express the characteristics of an electron. Oftentimes we call this the address of the electron. What's really interesting is that no 2 electrons have the same 4 quantum numbers. They can have the first 3 quantum numbers, but again, one electron is spinning in one direction and the other electron would be spinning in the opposite direction. You never have 2 electrons spinning in the same direction in the same orbital. So what I know from the quantum numbers for an electron. Here's an address. Here are the first 4 quantum numbers. 1, 0, 0, positive 1/2. What do these numbers tell me? Well, I know the first quantum number is the energy level. N equals 1. that means there's only one shape of the orbital. The second quantum number tells me that. That's the L value. L equals 0. Well, when L equals 0, that corresponds to a specific shape of an orbital, the s orbital. M sub L is 0. That tells me the orientation. And because the s orbital is a sphere, kind of like a marble or a softball or a basketball, depends on the size. In this case, n equals 1, it's probably the size of a round pea. All right, if I could actually measure it. But m sub L is 0, that means it's on the x, y, and z axes. And then positive a half would tell me that it's spinning clockwise. So again, this is what I just stated. The first number, first principal energy level. The second number is the s orbital. The third number encompasses the orientation in the x, y, z axes. And the fourth number means that it's spinning clockwise. Positive a half is clockwise, negative a half is counterclockwise. Let's see if you can try this one. We have 3, 1, negative 1, and negative a half. So what do these 4 quantum numbers tell us? Well, when n is 3, we're talking about the third principal energy level. L is 1. Anytime L is 1, that corresponds to a p orbital. M sub L is negative 1. Remember, all possible M sub L values when L is 1 is negative 1, 0, and positive 1. We randomly assign px to the negative 1 value, py to the m sub L 0 value, and pz to the m sub L positive 1 value. So if m sub L is negative 1, this is specifically telling me the orientation of the p orbital. It's the px orbital. And then when m sub s is negative a half, we're talking about counterclockwise spin. So, just to refresh our memories, we know that the 4 quantum numbers